vertical reinforcement is like the column right here. Alright, I think that's most important things that I have to discuss, and I don't know how long it is now. Maybe we should continue. There's more I have to discuss, but we're running out of time. Some people do not watch the whole video because they're not interested. So, but there's more you can learn, and the actual reason of also this one here. And again, the overlapping here is 1.5 feet. You convert that in between the cut here, and the here is this is the bearing between these two. Okay, in architecture, the cut bars, the top, the cut there, and the bottom bar. And for civil engineering, I don't cut it, and I have to incline. I have to continue the top bar there going down here in a 45-degree angle, same as the picture there in the first video about foundation design that I was talking about. And this is an architecture style of layout. Same thing there, but I just avoid cutting it. The bottom bar here is cut there in this architecture drawing that I do. And for civil engineering, we don't cut it. It's from here and go all the way up and going to the top of the midsection of the combined footing. The reason why, you may ask, why is below the column the reinforcement is in the bottom, and why is in the midsection is on top? Yeah. Why is in the midsection is the top bar, and the bottom of the column is the bottom bar? That question will be answered in the next video. I still have lots to explain here. So we're only page 58. Calculation right there. All the way, same procedure. There's a lot of work for this book, and you're gonna have spend a lot of time watching this video, but you might as well get this book and you just put in your shelf and use it when it's ready. Right? Here's the shear moment diagram for that combined footing right here. In the shear moment diagram for combined footing, this should be another video anyways, it's very long now. For the shear moment diagram for the combined footing, first thing you gotta make sure is for the shear values here to be 0 right there at the end. From the beginning here, 0 here, and according to your calculations, make sure you end up 0 right here, because if not you have to go back and recalculate them. So make sure if you sum up all the shear to be 0 right here at the end, at point F it should be 0. Once it is 0, you're ready to solve for the maximum moment. The maximum moment between these two loads, two column loads, the exterior column and the interior column loads, maximum moment occurs at that point there, somewhere in the middle. Depends on the balance of this load. The other load is bigger and the other load is smaller, so it's gonna be more of this side or that side. So but it is as always for the combined footing, it is in between that column, maximum moment. The reason why you need a maximum moment is that is the moment you're gonna design the midsection of the combined footing, the reinforcement. And make sure when you design a foundation, make sure you use the ultimate strength design. The reason why I say that to use the ultimate strength design, because the ultimate strength design uses according to the ACI code recommendation. I always use ACI code all the way since the beginning of since I was a student. I use ACI code. Alright, that's the most reliable reference that you can refer to in terms of reinforced concrete design. They are the people that study all the way about concrete structure. So there's no other organization in the world that is better than the ACI people. Committee number 318. It's from the United States. I'm here in Canada, but I'm using all the way the ACI code. I don't even look at my code. Okay, the shear moment diagrams, I said make sure it's 0 here at the shear, or else you gotta recalculate because your moment is gonna be wrong, right? And the exact location of the 0 moment is right here. There's calculation for that where, alright? And there's a lot of work for this and the techniques how to design the combined footing. Once you have that 0, then you're confident that for sure the maximum moment is right here at the mid, and calculate the area there, then you get the maximum moment. And there's more to discuss about this, why the reinforcement in the mid section of the footing is on top, and why it is that the reinforcement below or under the column is on the bottom of the foundation. And that is the question that I'm gonna ask you if you apply a job. You know, for me, if I'm interviewing you, I'll be asking you why. Why is the combined footing reinforcement at the midsection is on top, and on the column portion is in the bottom? If you don't have an answer for that, then you don't know. You don't know what you're doing, right? I'm gonna do another video for that. There's more to discuss here. This is a real number page 41, and now I'm gonna show you the here's the actual books that I wrote. This is, I'm still writing the foundation design in concrete structure. This is the pages that I'm showing you. The pages that I'm showing you is in this book, but I'm still doing it. It's very long. It's not done yet. So you better off get that book. This book here, the reinforce the foundation design in concrete structure. There's more book that I wrote right there. And this is a lot of work. The moment distribution programming. This is for the moment distribution. There's more to discuss, but I'm gonna make another video. But before I go, I gotta show you the. I gotta show you about the. Let's go to the other computer, the other screen. The next computer right there, the quadratic equation. You know quadratic equations, very simple. What is it? Right, yeah. Quadratic equation. Quadratic equation example, there's the equation there, 10x squared plus 15x minus 5 equals to 0. Equals to 0, find value of x using quadratic formula. Here's the formula. A is 10, 15, B and C is a minus 5 equals to 0. First you gotta solve this. B squared equals 425, and the 2a is 20. You gotta calculate all that first before you substitute it to this general equation right here. So there are two signs here, plus and minus, and here I put plus the first x1, and the x2, here's the minus, and here's the b squared minus 4ac. B squared minus 4ac is 425. The square root of that is 20.615, and the substitute all the values, you get this. X1 is 0.281, and the x2, this is negative, okay, because the quotient of two number having a like sign is always negative, right? Because the product of number having like sign is always positive. So this is negative, and so this is the root that you have to consider. If you're designing foundation design, then that's the root that you're going to use in your design. Okay, now this is the manual calculations. Now I'm going to show you the program that. Even I have the program, the Python programming. When you write a book, you still have to type it. Okay, I'm going to show you the how quick is the program will give you that answer there, the 0.281 and the minus 1.781. In the program, all you gotta do is enter this data here. These are variables. You can change this anytime. Alright, and give you the program will give you the answer. I program it in a way that the program will prompt you for this, to enter this. Alright, and then the program will calculate itself to give you the answer of x1 and x2. Here's the example of Python programming. I use Python 2.7, and you have to have a text editor, Notepad++. And for Python 2.7, you use the CMD, the internal command. That's why I don't like the Python 3.4.5. I don't like it because the display of the output is very small. You can't even see it. But this one here, very wide. Okay. Now here we go. I'll show you that. You gotta key it in. The 10, 15, and minus 5 give you the answer. This is the other computer. It's computer number 2, 3. I have 5 computers to use for the design. Okay, now okay, now the program is asking you to enter A. What is your A? Is 10. 0. You gotta put 0.0 so that the remainder it's secured. And what is B? Is 15. I enter that 15. See that 15. The program asks me now for the C. C is minus 5, and I enter the minus 5. Once you complete all the entries there, if you hit the enter button, the enter button there, it gives you immediately the answer of that, the same answer as that one there. There we go. See, the x1 is 2.81, x2 is minus 1.781. Is exactly the same as in the manual calculation. The advantage of the program is it's so quick. That's why I use it in my beam, slab, columns very quickly. Very quick, but the process of programming it is long. You gotta, but after that you'll be laughing. So that's the power of the Python 2.7 language. that I use in my programming. It helps you a lot. If you are a student, then you don't need that manual calculation. You need a program, man. There's no way of you get tired, and that's why you gotta slack up and fail your exam because you don't have the program. You need a program. I don't know how to help you about the programming. Yeah, you can send your calculation to me and I send you the answer back using my program. So, alright, see, I just thought that this is the beginning of the foundation design lecture. This is a very long lecture. Sorry about that. But at least you see all the process and the importance of Python programming. If I were you, if you want me to help you, you have to have Python 2.7 active and working, and also the Notepad++ text editor. So maybe I can help you if I have time. Right? Thanks you for watching. See you for the next video. This is the video number 1 for foundation design. There's a lot of foundations to be designed. I just don't have time. And now I got time, and we don't have to work. We shut down for 1 month, I think, more than that. I wish it's 1 year. So, all right. Hey, thanks for watching, and don't forget to subscribe. This subscription thing, helps me. But the YouTube, they have lots of requirements, so I don't care about that. I just care about helping people. And what's real? There are false profit in structural designers in YouTube. Alright, okay, thanks very much for watching. Bye.